So this is a lesson plan all about reversible and irreversible changes in matter. It's modified to fit a second grade Georgia standard, and you can easily use the same lesson plan format in a fifth grade classroom as well, just using the physical and chemical changes terminology to fit that standard as well. We're going to jump right into my Engage here, where the students will be watching a video of ice freezing, and I'll ask them some questions about what's happening in the video and if they think they can get the ice to change back to its original state, which is water. Okay, so what do y'all think is happening in that video?
It's getting.
Raise your hand and tell me. Just raise your hand. Lizzie, what do you think is happening?
So they put baking soda in the water, and the baking soda was cold, so
There was freezing going on, but it wasn't baking soda. It was actually what else?
cold air.
What do you think it was, Piper?
Like the holes, and it's like in the season, like winter, and it's really cold, and it could be freezing the water through the cup.
That's exactly what's happening. It's cold. It's weird. The water's being frozen, which usually happens in the winter. So, has anyone ever seen this before? Has anyone seen frozen thing outside that are frozen? Have you ever slipped on something frozen? Yeah? Yeah? Where was that?
It was at my house, and I got it. Ouch.
Oh, well, what happens when it gets too cold outside? When it gets too cold?
When you just put water out, go back into the house for 1 minute. When you come out, the water.
You guys think that we could change this water back from ice, a solid, because y'all know about that,
Yeah.
back to a liquid?
Yeah.
How do you guys think that we would do that?
Put it in the sun.
Put it in the sun? Yeah, that's awesome. What's another way we could do it? Maybe,
Bring it inside and put it
in the microwave. Okay, that might be another way we could do it. What about you, James?
Put it in the oven and make it really, really hot.
Make it really, really hot until it goes, and then it'll go back to water. You think?
Boiling water.
Water, you think?
Boiling.
You think it's gonna boil?
Yeah.
The next video we watched was a log burning on the fire. Have y'all ever seen this at a campsite? Have y'all ever been to a campfire or had this in your house?
Yeah. I've had it.
Yeah.
My Nana's had one of those in her house before.
Oh. Okay, so pay attention. What I really want you guys to pay attention to is this. What is this right here?
Fire.
Fire, but what is on fire?
Log.
The log is on fire.
Or wood.
Yes, the wood. Good job. So what is the wood? Where's the wood going?
It's burning. It's burning down. And turning into ashes. No, it's turning into dust.
That's good. That's good. I like where we're going here. So when does the wood turn into ash?
When it burns.
When it's burning, right? When it's on fire? So when the wood is turned into ash, is it still wood?
No.
Or is it now something completely different?
It's something completely different. Ashes. Ashes is stuff that's like paper.
Do you guys think that we could ever get the ash to turn back into wood?
No.
How might we do that if you thought that we could?
God would do it. God would do it. You would probably have to like work with God.
What do you think? Do you think there's a way that we can get it back? No, there's really nothing we can do. Y'all don't think?
You can glue it.
I need some idea. Somebody's gotta have some kind of crazy idea.
Oh.
What do you have?
One time I read this book and it said that some kind of water came flowing out of this big thing, and then there was this Hawaii thing that made it somehow turn into wood.
Oh my goodness, that's so funny. That's so funny.
Moving right along into the Explorer portion of the lesson, the students will be completing this activity with Alka-Seltzer and water.
What kind of state, because I know y'all learned about states this week, so what kind of state did y'all think this is in? solid. Yeah, it's in the solid state. So, if I broke it in half, one person from your table, whoever's got it in their hand right now, can break it in half. Let's do it.
Break it.
Now, if I wanted to, right, I could put these back together, no problem. Right? I could just put it back together, and it would be fine. Right? So it's broken. So it's broken. But I could put it back together, not right. Okay.
And then it may fall apart still.
It may fall apart still in the water. In 3, 2, 1. I'm gonna count you down. Ready? 3, 2, 1.
It looks like that.
Okay, so wait, what's going on with it? Come on, guys. Look at it. Okay, so it started dissolving. That's a good word.
I can see. It looks like it's turning into Sprite. It doesn't look Sprite.
What? Does it look like it?
Oh wow. I think it's pretty bath ball.
It looks like Sprite.
It does look like a bath bomb. Okay.
It looks like a bath ball.
So this cup, it looks like lemonade?
It looks like
No, it's like lemonade. So it's
They do it
It's bubbly.
It looks like Sprite.
Dissolving.
Yeah, it actually does. Diet Sprite. Diet Sprite.
Okay.
No,
So now, guys, how will we get the tablet out of there? How will we get the tablet out of that cup? Why? Why can't we? It turned into liquid. Oh my gosh. Okay, so we can't. So you don't think that we can get the tablet back?
Oh, we can freeze it.
We can freeze it, but can we get the tablet? How?
We can get another one.
We could get another one.
That's
Yes.
the smart tool.
Did you not put the? Look. Okay. So what do you see about it? What do you notice? It's dissolving. Oh my goodness. It does look like a bath bomb. That's a really good observation.
smells like Sprite.
There was a little bit of a setup that took place, and I don't actually have video footage of the students watching the video, but the video can be found here, and I put the link. I don't know if y'all could click on the link, but I'll put it in the description. And now moving to the Explain.
Raise your hand and give me your kind of best observation that you thought you had. Sprite? You thought it looked like Sprite and it did kind of look like Sprite, didn't it? What? Lemonade. Okay. So what really happened when you dropped
The
tablet in? What kind of started happening?
It dissolved.
It did dissolve. It started dissolving. What else did it start doing?
And the water started fizzing up.
That's right. Oh my goodness. Okay, so, and is there anything else that y'all know could tell me about the water you noticed?
The tablet was breaking apart.
The tablet was
And it was
breaking.
turning smaller and smaller and then
Until it got
Right. Okay. And then I asked you a little bit. I asked you if you, or how we would get the tablet back. So how do you guys think we get the tablet back?
We did. They take the whole thing out and another tablet.
Just get another tablet. But how would I take that one out? I really want that one back. How would I get that one back?
You couldn't.
I can.
You could just pour it into a cap. You can pour it into
Oh, wow,
a
dude. Look at William.
Okay. You can't get it back.
William, look.
I can't get it back.
No, stop.
Okay.
Like now it's
So
part
in
of the water.
So in matter, because we've been talking about matter a lot this week, in matter there are two types of changes that happen, that occur within matter and the way things are made up. And one of them is called a reversible change. Does anyone know what the word reversible means? What might that mean? To go back. So a reversible change. So what would be a good example of a reversible change that we just saw? Reversible means to go back. So it means that when something is changed, it can do what, Zevin?
Well, when water becomes ice, it can go back into water.
Yes, that's really good. Yes, thank you. I was hoping somebody would talk about that. Okay, so the ice video. I'm not sure I'm wondering what was up with that. But it's because it's a reversible change, like Zevin pointed out. It can be, ice can be frozen,
and then it can be heated up to be liquid, and it can be heated up even more to become a what?
Gas.
That's right. It's a reversible state. That's exactly right. And an irreversible change.
You can't reverse. Such as a tablet.
Irreversible. The tablet. Yes, that's a good example.
And such as the ashes.
The ashes are irreversible as well. So what I really wanted y'all to get out of that activity that I just showed you is that we can reversibly change the tablet by breaking it, because we did see that, right? We saw that happen. So when I broke it, I could put it back together, right? It didn't, nothing really changed that much about it, but when we saw the bubbles, and when we put it in the water, and when it melted down, when it dissolved, we knew that we couldn't get it back, right? So that's something. What do you think? How do you know when you can't reverse a change? Like, what's some signs? Like, what were some of the big signs that we saw with the tablet? Gracie? Huh? It went invisible, that's right. It did.
It destroyed and you didn't even see it at all.
Yes, it did. But, okay, so a big sign that the change is irreversible, meaning you can't get it back, is bubbles, okay? So when we see bubbles, we know that we probably won't be able to get that thing back, or we probably won't be able to change it back, right? So that's a really good thing to think about. And then another good thing to think about is when we see it change color. If we see it change one color, it's really hard to get it back to another color. And there might not even be a way possible to do that. And there probably isn't if it changes color.
You can just
So
You can just make it get a different color.
maybe.
I know what.
Maybe.
If it's a color change.
But anyway, so we're gonna watch this video really quickly.
Yay.
So what I'm doing here is kind of reminding them of the safety precautions we talked about beforehand. This was a brief reminder, but we did spend time talking about all of the safety regulations before I began the lesson.
Trying to make a mess with it too, okay? Alright, so the first one I want y'all to do, try mixing this and that. So it's going to be this ice water, this ice. It's got some water in it, but there's ice in it. And I want you to mix it with this water right here.
This was the first mixture we did, and it was the ice and the warm water, and they found out that this was a reversible change. I thought this was a really good way to show the students a reversible change that they had already kind of seen from the videos we watched.
Alright, so go ahead and pour it. Do you want to pour it? She can pour it. Y'all can do this. Oh, no, not there, not there. You're going to want to pour it into this. It's into this. It's not into the cup. It's into this. Okay? Everything we're going to be doing is in the cup. So do you want to do it?
Ray, did you pour it?
Yeah, I'll pour it a little bit.
Oh my gosh, the ice turning smells so fast.
Alright, y'all see what happened to the ice? The ice is gone. The ice will continue to melt and continue to disappear. Right? Because that's what happens to ice, right? Ice will continue to melt and disappear. Huh?
Yes, it is.
The next thing I want y'all to pick up, just pick it up. So it's going to look like this bottle of water. Nope, it's going to look like the water. It's going to look like this bottle of water right here. But it's not water, actually. It's called vinegar, right? Okay. So,
I taste vinegar. I love vinegar.
so we're going to do, and this only takes a little bit. So I want y'all to be very, 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 very hesitant, gentle-handed when you do this, okay? So there's that. Okay, so I want y'all to take a little pinch of the white on when I tell you to. Take a tiny pinch of this white
Nancy tells you to.
and put it inside of this tube. Okay? And then I want y'all to see what happens, okay? I want y'all to make it. Okay, so the second mixture we did was vinegar and baking soda, and this would produce bubbles. So in the explain, I explained that the bubbles would indicate that the mixture was irreversible. And that's what they would come to find out in a minute. Put a little bit in, and if you don't see anything happen, you can put a little more. No, you can't use this. Do not use this yet. This is not. Okay, so what's happening, guys? What do you think is happening?
It's freezing.
It's freezing. What do y'all think is happening? What's happening? Ooh! Ooh! Look at there!
Yeah.
Look at all of that.
Well, they put a little bit more. Yeah, barely anything was happening.
Just a little bit more. You can if you kiss. It doesn't take much, but I don't want you to put too much in there. Alright, so what are one of the things I talked about when I was up here?
Water equals soap. I did not know that.
What's one of the things that I talked about that might be a clue as to if we had a reversible or irreversible change?
I think that irreversible because it's bubbling. Don't put too much.
Irreversible because it's. Did y'all hear Zevins?
It's fizzing and bubbling.
Did y'all hear what Zevins? So guys, this class.
Yes.
So we're gonna move on. Okay. So.
Give up the J.
Okay, so I put a little too much in this one. My bad. That was completely my bad. So this is what is this is what happens when you boil purple cabbage. Okay. Purple cabbage. So what happens to the purple cabbage is that some of the purple will come off, and this is what we're left with for the water. I want you, because I know that none of y'all have been using your pipette. None of y'all have been using that yet.
Now we'll be using it.
Now we will be using it
Told you.
in the purple. So this is what I want you to do. There's soap on your plate. I want you to squeeze the pipette. Can everybody see what I'm doing?
Get the pipette.
I want you to squeeze the pipette like that onto the soap. And then it's going to suck some soap into it. Okay, so you're gonna get a little bit of soap. And what I want you to do with that soap is I want you to put it inside of the purple cabbage water. So the third mixture was purple cabbage water and soap. And I thought they would think this was so cool too, to watch it change colors. So it is actually going to turn blue, a bluish green, depending on how much they use. So that would indicate an irreversible change. So the soap was clear, right?
Yeah.
But what did it turn into?
Blue.
It turned blue.
It gets more soap the more you shake it, kind of.
All right, now I want you to put another thing?
made soap.
What's another thing that we talked about that could be a clue that it's irreversible? Class, class.
Yes, yes.
Class, class.
Yes, yes.
Class, class.
Yes, yes.
Thank you. Thank you. Thank you. Thank you. All right. So what color did it turn? Oh, that's beautiful, isn't it? That's so pretty. And it started off as what?
Purple.
It did start off as purple. Isn't that crazy? Something clear can make it blue, and that's so cool. I know. Isn't that funny?
My turn.
Who would have thought, right? Okay, so we only have one more to do.
My turn.
One more.
Evan just asked me a really good question. He asked if that was the stuff in an hourglass. Actually, it's salt.
I thought it was sugar.
No, it's not. So the last one that we're going to be working with is this one, the one with the white at the bottom. And it does kind of look like sand from hourglass, you know. Okay, so what I want y'all to do is I want y'all to class. Go ahead and open them. And then I want you to slowly pour the water in your cup. So the last mixture was the water and the salt, and this was an example of a reversible change. This one was a little bit trickier, but they were able to figure that out, as you'll see here. No.
Okay, put the cap on just in case.
Just salt and water.
He said don't shake it. Salt water.
It is making some water. It's
Like
like
seawater, but it doesn't look like seawater.
Okay, so can anyone tell me? Okay, Lizzie, that looks really good. Lizzie, you did a really good job. So what do we see at the bottom? The salt is still at the bottom, right? Ooh, y'all looks great! Oh my gosh, way to go!
Can I hold it?
In a minute, you can, sure. But we still see the salt at the bottom, right? So do you think that we could get the salt out of the water?
Yes.
You do? Why do you think that?
Because it's still there.
Yeah, it is. And we can still probably figure out a way. How would we separate it? You don't think we can? Because it's so little.
Yeah, and probably
What do you
because the water.
You can do this with your hand or something that has like that tiny of a hole. And then, or you could just cut the top off of it. You could just cut the top off of it.
I like what you think. What do you think, Evan?
Well, I think you can just have a little hole right there. And just some salt is actually like a little bit bigger than usual,
Right.
So they'll have the big pieces in there, and the little pieces just pretty much don't matter.
That there is actually machines that can take salt out of water, that can separate salt from water.
Isn't that how, like it can take salt out of salt water?
Hold on, there's too many people talking. I can't hear when there's too many people talking.
Don't they get salt water from the sea and then they have to drink all the salt out of it?
Yeah.
How do they do that?
That's how you get salt?
That's how, well, that's a way to get
I
salt.
think I know how they do it.
How
They
do
put
it?
the salt somewhere where it dries out and the water becomes gas. No, salt is
Maybe. I like the way you're thinking science, though. I need this table.
That's my hypothesis.
So, what did y'all learn about reversible and irreversible change? For the final part of the lesson is the evaluate part, and the students already knew that they were going to participate in a journaling activity for me. But I wanted to make sure that we had a lot of reflection so that they would have good ideas to be able to complete the journaling activity and be able to really define those definitions of reversible and irreversible changes.
How do you know? Okay, so what Jeff said was it had bubbles. So there are some bubbles at the top here, right? And it changed colors. It did, it changed colors. And that was one of the clues that we had. Yes.
Remember how we went in there and it just dissolved?
Yes, that's right. He's using the tablet example again. That's awesome.
It also fizzed up.
It did. It sure did. All right, can someone else give me another example of an irreversible change? Anybody? Oh, don't be shy. You got there.
The tablet that fell into the water.
Yes, that one pointed that out too.
already said that.
That's awesome. Thank you so much for remembering that. Okay, what's another one?
How'd you get the big one? I know another one. I think I do.
Ellie.
The salt thing where you could reverse it from the when you put the salt.
That's a great example of reversible. What does reversible mean?
Reversible means that take like you do if you do something and then you put it in to make it change into something and it changes into and it can change into.
It can change back, right? That's a good observation. Or no, that's exactly right. So the salt would be example of what? Reversible or irreversible? Reversible, that's right. Awesome. Can you think of one for irreversible?
Irreversible. No bubbling.
The color thing. And there's one, too. Do y'all remember the one that we did in the middle?
Look at this. This is one that I'm guessing is irreversible. It's so bubbly.
Yes. Okay, so do y'all remember what was in that? You remember what was in that one?
Well, you know the garlic one's irreversible. The garlic one's irreversible.
The garlic.
You know, the one
Oh, yes, it was.
I do.
Yes, it was. Okay, you made the cabbage. Okay, yes, that's the one that Jeff pointed out. There's one more. There's one more. What was the last one?
well, pretty much the vinegar that fell into like, you know.
The vinegar. Yes, the baking soda and vinegar.
Say.
Yes. The baking soda and vinegar. That one bubbled up. Okay, so Ellie, will you give me that definition you just gave me of reversible again?
I already said reversible.
Reversible.
Oh, reversible, where you can where there is something and then you can turn it into something and then you turn it back to what it was before.
Yes, so we can change it back, right, guys?
I also said this.
All right. So what is an example of a reversible thing we saw today? We broke the tablet. That was reversible. Good job. Yes. Right? A reversible change. What about the ice?
Oh, you can melt ice and then you could freeze it back.
Yes, that's a good one. All right. What about you, Aunt? Can you think of one that's reversible?
If anyone's in a yellow house,
So now we're kind of winding down with our discussions,
Yes,
and they're
good
about
job.
to move into the journaling activity
Okay. So
where they will
now
be
I
defining
Oh, what's up?
the definitions of reversible and irreversible changes,
I love it. Thank
as well as naming examples from what they saw in the activity.
So now we're going to do the journal. It's going to be on reversible and irreversible change. So this side says what is a reversible change and what is an example. And on the back it's the same thing. What's an irreversible change and what's an example of it. So you all write down your best, do your best, and I'll be here if you need any help.
Whew, I know y'all can tell I'm losing my voice, but the 5E lesson plan went awesome. According to the journal entries, they did an excellent job of understanding the difference in irreversible and reversible changes in matter. Like I said before, this can be easily integrated into a 5th grade classroom as well, just using the physical and chemical changes. So all in all, I think it was an awesome success, and I can't wait to do another one soon.